This is one of the questions from your textbook, page 308, question number 15. We've got on May 16th, somebody has invested $30,000, May 16, 2014, and the investment is invested at 3.75% compounded semi-annually. On April 27, 2016, the interest rate changes to 4.25% compounded monthly. And the question is, how much will the investor have at the end of that time period, at the end of December 29, 2020? And so we need to find out what the maturity value is. And so you can see that this is going to be a two-step problem. Step one is going to be to find the value on the April 27th date at the 3.75% compounded semi-annual rate, and then step two will be to find the amount on December 29th. But before we can do any of that, what we need to do is to find how much time has elapsed between May 16th, 2014 and April 27, 2016. And for that, you're going to be using the days between days function on your calculator. So right away, you're going to go to days between days on your calculator, and for date number 1, you will enter in 05.16.14 and make sure that you hit the enter key. And once you've hit the enter key, you will be prompted to enter in date 2. And date 2, of course, will be the second date, April 27, 2016. So you're going to be keying in for that second date 04, because April is the 4th month, 27 and 0.16. And again, make sure that you hit the enter key. The next item that shall come up on your screen display with the days between days function is DBD. And for DBD, that will allow you to hit the compute key, CPT or compute, and this will work out to be a value of exactly 712 days. And now what you're going to do is you're going to use the down arrow button or the cursor down button to go back to date 1 and date 2, because we already now have established that there's 712 days between these two days. Now what we're going to do is we're going to use April 27, 2016 as date number 1, and then we will use December 29, 2020 as date number 2. Date 2. And so once we've entered in for our new dates, date number 1 will be equal to 04.27.16. Press the enter key again, and you will be located right at the screen for date number 2. And for date number 2, you're going to key in 12.29.20. Press the enter key and then go down to days between days, and then press the compute, CPT, and your calculator will compute for you that you've got a total of 1,707 days between those two dates. And that's the important information that you need before you can carry on any further in this problem. So you've got 1707 days between those two days. Now let's use that information to determine how much time it is in terms of interest periods, because when you're using your interest or compound interest calculations, you can only use N as being the number of interest periods. And now what we're going to do is we're going to convert 712 days into semi-annual periods, and the way we're going to do that is by entering in 712, and I'm going to convert it to years first. So how do I convert 712 days to years? Well, the way I'm going to convert it to years is by dividing by 365. And if I take 712 divided by 365, I'm going to get a number which is 1.95 and so on years. Do not round off. Do not clear your calculator. This is going to be in years. Now I want to convert it to semi-annual periods. So whatever that number is on your calculator display, now I want you to multiply it by 2 so that you can convert it to semi-annual periods. And that will give you a value of 3.9 and so on, 3.9 and so on. What I want you to do is to store that number in memory 1, because I don't want you to round off. So store the entire value in memory 1. That's going to be your end value. And now you repeat the process for the second time period. And for the second time period where the interest is changed to 4.25% compounded monthly, we have 1,707 days. And how do I convert that into number of monthly periods? Well, the way we're going to do that is we're going to start off again doing the same thing. We've got 707 days, and we're going to divide that by 365 so that we can get years. And when I divide that by 365, I'm going to get a number such as 4.676 and so on, and that's in years. And you'll notice that I did not round off, so do not round off. Leave everything on your calculator display. And now we have a number of years, and we need to convert that into how many monthly periods. Well, how do I convert from years to monthly periods? Well, we're going to do that by multiplying by 12, because there are 12 months in every year. And when you can do that conversion, you will get an n value that is 56.1205 and so on, and that will be in monthly periods. And again, do not round off. No rounding until the bitter end, people. So what I would like you to do now is to store this in memory 2. So now we have the first time period in memory 1, and we have the second time period in memory 2. And now we can use our built-in functions to compute the future value. And this is going to be done in several steps. Step 1 is going to be set the present value to $30,000, and we're going to enter the IY value. The IY value is 3.75%, and the compounding periods per year, CY, is 2 because it's compounded semi-annually, and there are no payments. So the PMT value is 0, and the N value is equal to whatever we get from memory 1. So I'm going to put in memory 1 for recall 1, and throw that into N, and now you can compute the future value of that. Now that future value is now going to be entered as the present value for the second time period. And so once you've entered in the present value, again you will now change the IY. IY will become 4.25. And the CY is also changed to 12 because there are 12 monthly periods in a year. And the N value is going to be whatever we get out of recall memory 2. So we're going to recall memory 2. And now what we will do is move in and compute CPT, compute the future value, and our future value should work out to be a value of $39,333.63. And so that's our future value, and of course we can see that the interest is $9,333.